Hi all, here's a quick little bit of background before you read Chapter 9 in Literacy Research Methodologies. Um, when we're talking about quantitative research, really we're talking about two possibilities in terms of the use of statistics in terms of conducting that research. The first is descriptive statistics, which is basically using numbers to describe things like what's the mean or the average or the median or the mode. As opposed to being able to make inferences about what's happening, i.e., what are some cause and effect relationships as a result of the numbers and the comparison of those means and averages. So, this slide, just to give you a sense, you'll start to, a lot of the terms that will start to pop up are things like population and sample and inferences and variability and distributions and covariates and just the use of statistics and parameters. As opposed to what we've been reading in terms of more qualitative uses of ethnography, case study, and discourse analysis. So if we were to compare the two, overall we'd say that statistics is a set of methods, procedures, and rules for organizing, summarizing, and interpreting information. But if we were to break that out, descriptive statistics are methods used to summarize, organize, and simplify data, whereas inferential statistics are methods that allow us to make generalizations about populations based on data from obtained samples. So that's a mouthful, but if we think of a population, something like all K through 5 ELL students, that might be a population. The way we can generalize to that population is by getting a robust enough sample of ELL students in K through 5 that could then, based on if the sample size is large enough and random enough, we can generalize that to all. So as I said, a population are all members of a particular group. For example, all NIU freshmen are all males over the age of 21, or all the schools in Illinois, whereas the sample is a subgroup of a population that is usually assumed to be representative of the population. So if my population is all NIU freshmen, maybe a sample might be 10 NIU freshmen selected at random. What would make it a poor sample, though, is if I selected 10 freshmen who all lived at Neptune Hall or something like that, because that wouldn't encapsulate all the variety of freshmen that attend NIU. Some live in the dorms, some don't. That's one example. So, of course, then there's going to be error, and what this was referred to as sampling error, which is the difference between the sample statistic, or the sample, and its corresponding population parameter. So what's the difference between those 10 NIU freshmen I choose and all NIU freshmen at large? Because I can't get data on all 10,000 NIU freshmen or 7,000 NIU freshmen, but I can get a sample on maybe 200. So the key then is to try to reduce error, to try to reduce the error between the sample that you choose and the population that it's supposed to be representing. And so there's two ways to look at this, and the chapter talks about this: internal validity and external validity. And internal validity is the accuracy in concluding that the outcome of an experiment is due to the independent variable, meaning that the outcome is actually caused by your intervention. So the intervention is the independent variable. So if I say, I'm going to see if literacy rates increase with all ELL students in K through 5, because I give them more direct vocabulary instruction. I want to make sure that that's the variable I'm really targeting, is that intervention, which is the targeted vocabulary instruction. So that's the independent variable. The dependent variable is the outcome. External validity is the extent to which the results of an experiment can be generalized. So that is, okay, it worked with this group that I experimented with. How well can I generalize it to all ELL students, for example? Excuse me. So there are threats to internal validity. So let's start with internal validity. Remember, this is the accuracy concluding that the outcome of the experiment is due to the actual intervention that you put into place. Well, there's history. So there's outside influences on participants during an experiment, which could be causing them to grow in their literacy rates. That has nothing to do with what you're doing. There's maturation. You see this especially with younger students. So, oh, look at their literacy rates are increasing. Well, yeah, kindergartners gain tremendously just as a result of moving from kindergarten to first grade over that course of the year. Um, there's the bias of selection. It could be from the participants who were selected. There could be sensitization due to a pretest. Your pretest may have given away. Could be a poorly designed pretest or something like that that sort of primed the pump for students to learn. There could be other biases due to testing procedures. Perhaps your instruments, the things that you're doing are culturally insensitive or privilege one group over another group. There's also something referred to regression or regression towards the mean, and that's the tendency for extreme scorers to move towards more typical performance when retested. So it might seem like something is happening, wow, look at all this, but actually if you did the test again, they'd actually perform just like everyone else. So they could be anomalies. And then there's something referred to as mortality, meaning you lose participants. They move, they leave the study, whatever. So all of those can be threats to internal validity. Your threats to external validity, this is your ability to generalize. These are some of them. Multiple treatment interference. So it's not just your direct vocabulary instruction that's happening, but they're also meeting with a reading specialist once a week, and they're doing independent reading in 2 of their classes 20 minutes a week. And so those could be interfering with your study. We talked about this this week in terms of people doing things differently for the researcher. In statistical studies, we refer to this as the Hawthorne effect, though. So they have knowledge about the experiment, and so then they start to change their behavior around because of the experiment. And then there's other experimenter effects just because they want to do well for because someone's in the room. And then again, there's that sensitization due to having a pretest, and then they know that they're going to try to do better on that post-test. So the big constructs, so one is validity, and the other one is reliability. So we've talked about internal and external validity, and that's that we're hitting the mark, not hitting the baby in the forehead. So that's a metaphor for thinking about validity. But then we also have something referred to as reliability. And that means if you did this experiment over and over, you'd hit that mark in the same place over and over. So when researchers talk about validity and reliability, remember that validity is the fact that what's happening as a result of your intervention, that's hitting the mark. And then reliability is that it's going to happen consistently, that if you do it over and over and over again, you're going to get the same results. It's not a one-time anomaly. And then there's this piece about generalizability, and that's one of the powers of statistical research, is that you can generalize it to the larger population. So you have the parameter, which is the value of a variable in the population. Remember, that's the big group. And then you have the statistic. And so we're dealing with statistics because we're dealing with the value of the variable in a sample. We can't get kids from all 50 states. We can't do the experiment in multiple places all at once. So we're going to choose a sample that's representative of that larger population. And so we use statistics to estimate or draw inferences about those parameters. And that's how we get to generalizability. And so a variable is any characteristic that can vary across individuals, groups, or objects. So things like age, reading level, grade point average, level of text anxiety. Those are just a few examples. And so this is something that I always still have to remind myself on, is that there's the independent and dependent variable. The independent variable is what is being manipulated. So I can manipulate on a number of different constructs. I could manipulate instruction. So group 1 is going to receive instruction from a basal reader, and group 2 is going to receive guided reading instruction. Or I can manipulate the condition. So one group is going to do their work on a computer, while the other one is going to do a traditional paper-based. Or I can change the task. So some are going to receive oral directions, and others are going to receive written directions. Or we're going to have oral sharing time of the story, whereas the other group is going to write summaries of the story. You could manipulate all 3 of these, but then you have a much more difficult time analyzing using more sophisticated statistical procedures, or most try to manipulate one variable. The dependent variable are the outcomes. And so 2 ways that are most often, the most common dependent variables are either scores on a test, whether that's a standardized test like a Stanford diagnostic, a Gates-McGinnity, any of those, an ACT, or they could be scores based on a local test, something that was created by the researcher. If it's created by the researcher, then they have to test those for validity and reliability. But that's one dependent variable. The other one that often we see are behaviors. And so we might see if there's a change in either observed or documented behaviors or self-reported behaviors. And those are the most common dependent variables. And then we measure these variables on 3 different levels. So there's nominal variables, and those are things that are categorical. So for example, gender, student classification, things like that. So we can put a number on it, but it's either 1 or 2, or 1, 2, or 3, or 1, 2, 3, or 4. Whereas you could also have ordinal data or ordinal variables where the objects can be ordered in terms of their magnitude, either more or less. So we have 400 kids, we can put them by a class rank. Or we have 400 kids, and we can put them from the 99th percentile to the 1th percentile. Or we can have something on scale, which is on an interval scale. Objects are not only ordered by magnitude, but we measure the distance between any 2 adjacent units that is equal to the distance between any other 2 adjacent units. A lot of stuff there, but what we're looking at is what's the distance between scores. So we could have any number of SAT scores or MAP scores or words per minute. I mean, you take something like words per minute, I mean, not that it could go to infinity, but you could have such a range of the number of words per minute, recorded in a 3-minute read aloud or something like that. So we have to think about the different, what are the variables being measured. And then I'm going to end on this slide because the rest we'll cover in class, but I'm hoping that this at least gives you enough of a background to help make sense of some of the more dense parts of the text. But when you're reading, so especially when you're reading the Beck and McEwen study, I just want to share this, that you're going to see some different symbols and notations, and they get kind of scary. I don't want you to run from them, but if you see a small n equals a number, that represents the sample size. Whereas you have the Greek letter mu, that represents the mean. So the mu equals, 13.76. That is the statistical notation for average. The sigma, the lowercase sigma, represents the standard deviation between the values, between the means. And then if you see a t with a parentheses, that means 2 groups are being compared. So that's the statistical difference between the 2. And then what will happen is they'll give a p-value to say if that t value is actually significant or not. If you see a f statistic, the capital F equals, that means 3 or more groups were compared. Okay, so a t-test is for 2 groups only, but an f statistic or an analysis of variance is conducted when you have 3 or more groups. And then what happens is you get that number, and that number doesn't mean anything until you see whether or not that represents a statistically significant difference between the groups. So if anything is less than 0.05, then that meant we have a 95% chance that the error is 5% or less, that the intervention either made a difference or didn't make a difference. And so those are going to be the common ones you're going to look at in that Beck study. So some questions that I'm going to ask, so you could use this as your annotation, because I'm going to ask this in class. When we look at the McEwen-Beck et al. Study, what is the sample? What is the population? What are the independent variables? What are the dependent variables? And what types of variables are used? Are they nominal, ordinal, scale, or all 3, or 2 of the 3? Okay, so have a wonderful week, and good luck with your reading.